On 12 November 1942, in the western desert of North Africa, a captured American light vehicle was found near the wreckage of a British supply convoy. Its crew had abandoned it after their position collapsed. According to standard Wehrmacht protocol, such equipment was usually destroyed or ignored. This time, however, a reconnaissance officer ordered a closer look. He summoned the unit's most experienced mechanic to determine whether the vehicle could be put to use. Within half an hour, the mechanic's inspection began to reshape long-held assumptions about German technical superiority. The shift in perception was gradual rather than dramatic. As each component was examined, the design philosophy behind the machine became clearer. A small plate on the dashboard identified it as a Willys MB, known to American troops simply as a Jeep. Opening the hood revealed the first surprise. The engine bay was organized with unusual clarity, clearly intended for rapid servicing by personnel with only basic training. Wires were color-coded, parts were labeled, and key components were positioned for easy access without specialized tools. The senior mechanic, with decades of experience on German military vehicles, had rarely encountered a design so focused on field maintenance. Fasteners were standardized and parts appeared interchangeable across vehicles of the same model, an approach clearly intended for mass production and quick replacement. The Jeep's Go Devil engine displaced 134 cubic inches and generated about 60 horsepower at 4,000 RPM. By German performance standards, those figures were modest. What stood out instead was the design philosophy: simplicity, reliability, and ease of manufacture. This was an engine meant to function dependably under harsh conditions and to be repaired by minimally trained soldiers using ordinary tools. It reflected an assumption that mechanics in combat might be farmhands or factory workers rather than highly specialized technicians. By late 1942, the contrast between American and German approaches to military vehicle production had become increasingly evident. The United States would eventually manufacture more than 640,000 Jeeps during the war, while Germany produced only a little over 50,000 Kübelwagen units. The disparity highlighted deeper differences in industrial strategy. The Jeep represented a system built on standardization, simplified assembly, and interchangeable parts designed for large-scale output by semi-skilled labor. When the officers returned, they asked whether the vehicle could be used. The senior mechanic responded cautiously, noting that the machine was exceptionally well suited to frontline conditions. One officer insisted that German engineering remained unmatched. Rather than argue, the mechanic pointed to the four-wheel drive system. A single lever engaged all four wheels, simple and intuitive. In contrast, German light vehicles required more complex procedures, and most lacked four-wheel drive altogether. Germany's main light utility vehicle, the Volkswagen Type 82 Kübelwagen, had many strengths. Designed by Ferdinand Porsche, it reflected meticulous German engineering. It was lighter than the Jeep, consumed less fuel, and used an air-cooled engine that eliminated the vulnerability of a radiator. Its major limitation, however, was that it drove only the rear wheels. In desert sand, mountain terrain, and the mud of the Eastern Front, that limitation proved significant. The Jeep, by comparison, could engage all four wheels whenever necessary, and its system was simple enough for any soldier to learn quickly. Further inspection reinforced these impressions. The Jeep's suspension relied on basic leaf springs, less refined than the Kübelwagen's torsion bars, but far easier to repair in the field. Its electrical system was straightforward and durable. The engine could operate on a wide range of fuel qualities without adjustment. Even its weight distribution drew attention. At roughly 2,450 pounds, it was heavier than the Kübelwagen's approximately 1,540 pounds, a difference of about 910 pounds. Yet its traction and versatility often offset that disadvantage in difficult terrain. German engineers would likely have judged the extra mass of the vehicle as a design defect, something that would sap speed and waste fuel. The mechanics who examined it, however, quickly realized there was logic behind what first looked like poor design. The added weight meant strength. Its structure had been intentionally reinforced, able to withstand rough handling that would ruin lighter machines. American designers had clearly prioritized endurance over ideal efficiency. They had created a vehicle assuming it would be overloaded, mishandled, and pushed into conditions few engineers would ever formally approve, and built it to keep working regardless. This was not the careless engineering portrayed in German training films. It reflected a practical philosophy grounded in real battlefield use rather than theoretical perfection. After retrieving the Jeep, the unit returned it to their forward area and spent 3 days putting it through intensive trials. It was driven across loose sand that bogged down German vehicles. It was overloaded beyond its official limits. It was subjected to treatment that would have disabled most transport, yet the Jeep kept operating. On soft terrain, where rear-wheel drive machines required careful maneuvering and often became stuck, this vehicle continued forward without hesitation. Its low-range gearing allowed it to crawl over obstacles at a walking pace, something German design struggled to match even with specialized gearing systems. News of the discovery spread quickly through the Afrika Korps. Here was an American vehicle outperforming its German counterpart in many practical ways. Officers and mechanics from neighboring units came to inspect it themselves. Their reactions tended to follow the same sequence: skepticism at first, then reluctant admiration, and finally concern as the implications became clear. One logistics officer with experience in pre-war German automotive factories spent hours studying the Jeep and offered a blunt conclusion. The difference, he said, lay in philosophy. German engineers pursued technical perfection. Americans aimed for designs that could be built quickly and in vast numbers. In a total war, he argued, the latter mattered more. He pointed out that the engine block was cast with broader tolerances rather than finely machined. This reduced peak performance slightly but dramatically increased production speed. Workers with only moderate training could assemble such engines far faster than their German equivalents. He noted the stamped metal body panels as well. Compared to German vehicles, they seemed crude, but they could be manufactured in huge quantities, even in factories that had once produced household goods. The United States had shifted much of its civilian industry into wartime output. Plants that once built refrigerators, washing machines, or commercial vehicles were now turning out military equipment. Germany, he admitted, could not match that scale. His remarks confirmed suspicions already forming among the officers. Germany's emphasis on precision and quality had clear advantages in peacetime. But in a global industrial war, the American model, producing good enough equipment rapidly and in enormous numbers, was proving highly effective. A mechanic later wrote a detailed technical report on the captured Jeep, cataloging its strengths and shortcomings. It was one of many such reports sent up the chain of command by German technical intelligence. Similar analyses from multiple fronts painted the same worrying picture. American industry was producing vehicles and equipment at rates that seemed almost unreal. By late 1942, German intelligence conducted a broader review of Allied production. The findings confirmed their fears. American factories were turning out military vehicles by the thousands each day. At peak output, Ford's Willow Run facility completed a B-24 bomber roughly every hour. Shipyards were launching Liberty ships faster than German forces could destroy them. Statistics showed that American vehicle production in 1942 alone exceeded the combined totals of Germany, Italy, and Japan, and it was still increasing. Within the unit that had captured the Jeep, the vehicle gained near-legendary status. Soldiers competed for the chance to drive it. Officers used it for reconnaissance missions, trusting it more than their own transports. When parts wore down, replacements were easily taken from other captured Jeeps. Components were standardized and interchangeable, making maintenance straightforward. By early 1943, dozens of Jeeps had been captured across the Afrika Korps. German mechanics informally shared repair knowledge and spare parts. A small black market developed for captured American vehicles and equipment. In desert conditions, a working Jeep became highly valued because of its reliability and adaptability. On May 13, 1943, the Afrika Korps surrendered in Tunisia. Roughly 250,000 German and Italian troops became prisoners of war. Their combat experience ended, but their exposure to American industrial capacity did not. During transport into captivity, the contrast between the two nations' logistical systems became unmistakable. American trucks moved prisoners in numbers that would have required horse-drawn transport in the German army. Liberty ships, which by 1943 could be built in just weeks, carried thousands across the Atlantic. At processing centers in North Africa, captured mechanics observed American motor pools in operation. Fleets of jeeps, trucks, and command vehicles were serviced efficiently by young soldiers with ample tools and readily available parts. Standardization meant that most vehicles shared common components, allowing mechanics to work on any of them without specialized training. Supplies arrived quickly, without lengthy bureaucratic delays. One American sergeant who spoke some German noticed a captured mechanic watching the activity and struck up a conversation. Learning that the prisoner had worked in vehicle maintenance, he offered to show him around. The war was over for the prisoner, he joked, so there was nothing left to steal. The informal tour that followed turned into an unexpected lesson. The sergeant explained American maintenance practices openly, describing a system designed for speed, simplicity, and constant operation principles that had helped sustain the vast machinery of Allied warfare. The American sergeant explained that their equipment was engineered with simplicity in mind. Most recruits had never worked on an engine before entering training, so vehicles were built so that almost anyone could repair them. Wiring was color-coded, bolts were standardized, and every part carried clear labels. Maintenance guides were written in plain language and supported with diagrams detailed enough for beginners to follow. The goal was straightforward. If a vehicle failed, any soldier should be able to get it running again without waiting for a specialist. A captured German mechanic studied a Jeep engine that had been taken apart. Each component was marked and organized. The manual offered clear illustrations and step-by-step instructions that required only basic mechanical understanding. When asked about production numbers, the sergeant admitted he didn't know the exact totals but estimated that thousands of vehicles rolled off assembly lines each week. There were so many Jeeps available that units often replaced a broken one immediately rather than repairing it on the spot. The scale was difficult to grasp. One supply base alone held more vehicles than some entire German divisions. The tour continued past Dodge trucks capable of hauling loads that would have needed multiple German transport vehicles, half-tracks produced in numbers that made their German counterparts seem scarce, and transporters designed to move tanks without damaging their tracks. The sergeant noted that lessons from the previous war had shaped American manufacturing. Parts were standardized across vehicle types. A bolt from a Jeep could fit a truck or a half-track, and many electrical and hydraulic components were interchangeable. This reduced the number of unique spare parts required and allowed factories to produce them in massive quantities. German observers realized that this common parts philosophy went beyond efficient production. It created a flexible logistical network where nearly any mechanic could service any vehicle and spare parts could be used across multiple platforms. The system reinforced itself, making repairs faster and supply chains simpler. As prisoners were transported from North Africa to camps in the United States, they saw the same pattern everywhere. At the port of Norfolk, Virginia, enormous volumes of cargo moved daily with mechanical precision. Cranes handled freight at speeds that would have required far more labor in European ports. Trains carried prisoners across the country in passenger cars that felt luxurious by comparison. Roads and depots were filled with vehicles, cars outside factories, convoys of trucks stretching along highways, and rows of military transports awaiting shipment overseas. At Camp Hearn in Texas, skilled German mechanics volunteered to work in the motor pool. American commanders accepted their help because the war effort needed every capable hand. For 2 years, these prisoners worked alongside U.S. soldiers maintaining the camp's fleet. American mechanics approached repairs with practicality rather than perfection. Their priority was keeping equipment operational. If something broke, they fixed it quickly with whatever was available. If parts were missing, they improvised. If a vehicle was beyond repair, they stripped usable components and requested a replacement, which often arrived within days. The German mechanics noted the contrast with their own training, which emphasized strict adherence to factory specifications and specialized tools. Under controlled conditions, that method produced excellent results. In wartime, however, the American approach, flexible, fast, and supported by abundant spare parts, proved far more effective. The camp's motor pool serviced hundreds of vehicles each month. Routine maintenance was completed in hours, and vehicles returned to duty almost immediately because replacement parts and tools were always on hand. One German mechanic befriended an American soldier who had worked at Ford's Willow Run plant before being drafted. He described the scale of bomber production there. By the time he left for military service, the factory was completing one B-24 Liberator every hour. That meant dozens per day and hundreds per month. The explanation, he said, was rooted in mass production methods developed before the war. Complex manufacturing tasks were broken down into simple, repeatable steps. Workers did not need advanced training if each person performed a single, clearly defined task. With enough workers repeating those tasks in sequence, output reached unprecedented levels. The contrast between the two wartime production systems was stark. German industry depended on highly trained craftsmen turning out well-engineered machines in limited numbers. The United States, by comparison, organized its factories around semi-skilled labor and standardized processes, producing functional equipment in enormous quantities. This difference was especially visible in the production of light military vehicles. American manufacturers such as Willys Overland and Ford built Jeeps to the same specifications. Parts from one company's vehicle could be installed directly into the others without modification. The benefit of this uniform approach was obvious. If one factory was damaged or delayed, another could continue manufacturing the same vehicle without disruption. Repairs were also simplified. Mechanics needed to learn the layout of a single standardized machine rather than dozens of variations. German forces faced the opposite situation. Their motor pools contained trucks from many manufacturers, each with different components and maintenance procedures. Staff cars came from multiple sources. Vehicles captured across Europe added further variety, each requiring distinct spare parts and technical knowledge. This lack of standardization made supply and repair operations complicated and inefficient. American logistics, in contrast, were streamlined through uniform design and interchangeable components. From the beginning, American planners emphasized ease of manufacture. When the U.S. Army issued its initial Jeep requirements in 1940, companies were given only 75 days to present a working prototype. Bantam completed one in just 49 days, after which Willys and Ford refined the design for mass production. Simplicity guided every decision. The vehicle had to be easy to build, easy to service, and easy to fix under combat conditions. German engineers might have favored more complex and refined solutions, but complexity slowed production. In a prolonged war, output mattered more than elegance. By mid-1944, rumors reached German prisoners about an Allied invasion of Western Europe. When confirmation of the Normandy landings arrived, many were unsurprised. The Allies possessed the industrial capacity to assemble fleets and armies on a scale Germany could not match. Reports described thousands of vehicles landing in the first wave alone. Jeeps, trucks, tanks, and amphibious machines carried across the Channel in specialized landing craft produced in vast numbers. The scope of the operation was immense. Thousands of ships, tens of thousands of aircraft, and more than 150,000 troops in the opening phase. Within weeks, millions of Allied soldiers would be operating in Europe, all supplied by factories capable of replacing equipment faster than it could be destroyed. Before the war, German confidence had rested heavily on perceived technological superiority. In many areas, German engineering was indeed advanced. Their tanks were often better armored and more heavily armed. Their aircraft and small arms were highly regarded, yet industrial scale outweighed technical refinement. The United States could build multiple tanks for every German one, far more trucks, and vastly more light vehicles. At one American camp, prisoners watched soldiers loading jeeps onto transport trucks bound for the port. Vehicles were driven up ramps and secured in quick succession. Dozens were ready for shipment in less than an hour. For one German mechanic, the number of vehicles in that single operation exceeded what his entire division had fielded in North Africa. Similar scenes were occurring across the United States daily. The arithmetic of industrial capacity was becoming undeniable. Germany had shifted its economy toward total war, diverting civilian industry to military use. Even so, its total production of military vehicles in 1943 remained under 100,000 units. The United States, while still maintaining a significant civilian economy, produced more than 2 million military vehicles in the same year. The difference was not only in volume but in design philosophy. American vehicles prioritized durability, simplicity, interchangeable parts, and straightforward operation qualities suited to sustained warfare. German vehicles, often designed with peacetime standards in mind, proved more difficult to maintain under continuous combat conditions. In November 1944, news spread of a German offensive in the Ardennes, later known as the Battle of the Bulge. The operation depended heavily on capturing Allied fuel supplies, as Germany's own reserves were dangerously low. Reports also circulated about a special commando mission in which German troops used captured American equipment to infiltrate Allied lines, underscoring how dependent operations had become on resources they could no longer produce in sufficient quantities. During the final phase of the war, certain German commandos were outfitted with seized American Jeeps, U.S. uniforms, and forged documents. Their mission was to slip behind Allied positions, spread confusion, and seize key bridges. The fact that even Otto Skorzeny, one of Hitler's most celebrated special operators and the man who had freed Mussolini, had to rely on captured American vehicles, spoke volumes about Germany's dwindling industrial resources. It revealed a military increasingly unable to supply its own forces. The infiltration effort ultimately failed. American military police exposed many of the disguised soldiers by questioning them about everyday U.S. life, procedures, and slang details the infiltrators often could not convincingly answer. Meanwhile, the broader Ardennes offensive slowed and then stalled. Although Allied resistance was determined, the decisive factor was logistical collapse. German armored units ran short of fuel. Tank crews abandoned vehicles when supply trucks failed to reach them. Infantry formations reverted to horse-drawn transport as motorized support systems broke down. By January 1945, the offensive had been contained and pushed back. As spring approached, Germany's defeat became unavoidable. Soviet forces advanced toward Berlin from the east, while American and British armies crossed the Rhine and pushed deep into German territory from the west. In prisoner of war camps, German mechanics continued servicing vehicles for the very armies that had defeated them. They felt neither pride nor humiliation, only a recognition that the war's outcome had been decided by industrial capacity as much as by battlefield skill. Germany's soldiers had not lacked courage or technical ability. They had confronted nations whose manufacturing power far exceeded their own. In April, word finally reached the camp. Germany had surrendered, and the war in Europe was over. The mechanics were unsurprised. Many had expected this for months. Their thoughts turned to the future. Repatriation would come, they were told, though not immediately. There were still administrative and logistical matters to resolve. One mechanic reflected on what awaited him. A homeland reduced to rubble, occupied by foreign armies, its cities devastated by the industrial strength that had produced the vehicles he had once studied. An American soldier asked him directly whether he had ever truly believed Germany could win. After some consideration, he answered honestly. Before the war, many Germans assumed that superior engineering and craftsmanship would outweigh sheer production volume. Pre-war American goods had often seemed less refined than German equivalents, leading to the belief that US military equipment would be similar, but that assumption proved wrong. When German mechanics first examined an American Jeep in 1942, they realized they had misunderstood the nature of modern industrial war. The Jeep was not necessarily more sophisticated in design than Germany's Kübelwagen. Instead, it was optimized for rapid mass production, durability, and ease of maintenance in harsh conditions. In a global conflict driven by output and logistics, those qualities mattered most. The American acknowledged the point. The United States produced equipment that was good enough, quickly made, and available in enormous numbers. The two men, once on opposite sides, stood in shared recognition of what had determined the war's result. Repatriation began late in 1945. German prisoners were transported home by ship. One former mechanic reached Germany in early 1946 and passed through Allied processing stations before being released. His city lay in ruins, reduced to debris and shattered buildings. Yet amid the destruction, he noticed something familiar: American vehicles everywhere. Jeeps carried officers through damaged streets, trucks delivered relief supplies. Motor pools operated with both Allied soldiers and German civilians working together. He approached one such facility and introduced himself to the American officer in charge. His English, learned during captivity, was functional. He explained that he had served as a mechanic in the Afrika Korps and had spent years maintaining American vehicles in a U.S. camp. The officer reviewed his documents and confirmed the details. Skilled mechanics were urgently needed. Many had been killed or remained in captivity. He was offered a civilian position, paid in occupation currency exchangeable for food and essentials, starting the next day. Thus, the former German soldier found employment maintaining the same types of vehicles he had once encountered as enemy equipment. The Allies required technical workers and he needed a livelihood. With the war concluded, practical realities took precedence. In the months that followed, he witnessed the early stages of Germany's reconstruction. Aid from the United States arrived steadily: food, medicine, and building supplies, distributed with the organizational efficiency that had also played a decisive role in winning the war. The equipment that reached post-war Germany largely arrived on American trucks and under the direction of USO planners who approached reconstruction with methodical organization. Within this system, a former German soldier found work in a motor pool where he began training young German civilians in American-style maintenance practices. Many trainees had once served in the Wehrmacht and now needed practical skills for life in a country that would no longer sustain a large military. He passed on what he had learned through observation, prioritized simplicity instead of technical showmanship, usefulness over perfection, and practical outcomes rather than abstract theory. These principles, drawn from American vehicle design and logistics, seemed well suited to the rebuilding of German industry. By 1947, his reliability and experience led to a promotion overseeing German civilian workers in the motor pool. The American officer in charge respected his knowledge and organizational ability. One evening, the officer asked for his thoughts on designing a vehicle for a newly rebuilding Germany. His answer reflected careful consideration. He suggested adopting American design logic but adjusting it for European realities. A vehicle smaller than a Jeep, more economical with fuel, yet built around shared components, straightforward repairs, and manufacturing efficiency rather than engineering prestige. Europe's narrow roads and limited fuel supplies required adaptation, but the reliability and production philosophy seen in American vehicles offered a strong foundation. The officer agreed, noting that Marshall Plan investment and the study of American industrial methods would shape Germany's recovery. Mass production in the American mold, modified for local needs, would define the future. In the years that followed, this forecast proved accurate. West German factories embraced American-style production systems while retaining their own reputation for precision. The combination helped transform a devastated economy into one of the world's strongest. Companies that had produced wartime vehicles shifted towards civilian markets. Volkswagen, once known for military models, grew into an international automotive force by blending German engineering discipline with large-scale manufacturing techniques learned from abroad. The Volkswagen Beetle became a symbol of this fusion: simple, durable, affordable, and built in enormous numbers for ordinary families. Former German mechanics who had worked with American equipment during captivity returned home carrying valuable experience. They had learned the advantages of standardized parts, efficient supply chains, and maintenance procedures designed for speed and reliability. They saw firsthand how designing vehicles for easy production rather than technical perfection enabled large output. These lessons shaped German automotive development for decades. Rather than reviving pre-war methods, manufacturers combined their own precision with American efficiency. By the early 1952s, the results were clear. Volkswagen dramatically increased output. Mercedes-Benz integrated assembly line practices while preserving quality. BMW reorganized production to use shared components across models. This blend contributed significantly to West Germany's economic recovery and export success during the 1952s and 1960s. Military historians also recognized the broader significance of American vehicle design. U.S. Army historian Hugh M. Cole recorded that captured German officers often expressed admiration for the Jeep above all other American weapons. Not heavy bombers, tanks, or artillery, but the Jeep. To them, it represented the industrial approach that had given the United States a decisive advantage. General George C. Marshall even described it as one of America's most important contributions to modern warfare. The vehicle embodied principles that extended beyond the battlefield. Standardization, simplified engineering, production-oriented design, and reliability over complexity. During the war, American forces studied captured German vehicles and published technical manuals explaining their operation and maintenance. By contrast, German troops who seized American Jeeps rarely needed detailed instructions. The vehicles were straightforward enough for mechanics to understand immediately. This difference highlighted contrasting design philosophies. German vehicles often required extensive documentation to explain intricate systems, while the Jeep's layout was intuitive and easy to service. Decades later, in the 1960 seconds, veterans who had served in North Africa began meeting to remember the war. Conversations inevitably turned to the vehicles they had relied on. Some former mechanics acknowledged that German designs were, in certain respects, more refined, lighter, fuel-efficient, and well-suited for desert conditions. Yet they also admitted that the Jeep proved more effective for modern warfare. Its four-wheel drive, standardized parts, ease of repair, and above all its ability to be produced in vast numbers gave it a decisive edge. Officers who had first encountered captured Jeeps early in the war initially dismissed them as crude. Over time, however, they recognized that what seemed basic was actually efficient. By the middle years of the conflict, many units preferred captured Jeeps because they performed more reliably in combat conditions. In retrospect, the exchange of ideas and techniques between American and German industries after the war helped reshape global manufacturing. The integration of German engineering discipline with American production methods produced vehicles and an industrial revival that neither approach alone could have achieved. Several former German servicemen later recalled a turning point that had little to do with any single battle. One of them described the moment he grasped that U.S. factories were turning out more military Jeeps in a single week than Germany could build Kübelwagens in an entire year. From then on, he said, the outcome seemed determined by arithmetic rather than tactics. No matter how hard German units fought, their opponents could replace vehicles and equipment faster than losses could be inflicted. Conversations among veterans often returned to that realization. German troops generally admired the Kübelwagen and regarded it as a capable design. Yet encounters with American Jeeps forced them to confront what those machines symbolized: a vast industrial base capable of sustaining modern warfare. The Jeep's battlefield usefulness mattered, but its real significance lay in what it revealed about the gap in manufacturing strength between the combatants. Throughout the conflict, the Wehrmacht struggled to keep its forces supplied. Even as late as 1943, roughly 4 out of 5 German divisions depended heavily on horse-drawn transport. At the beginning of the war, the German military fielded more than 500,000 horses. Over time, that number rose to nearly 2.75 million animals, with about 1.1 million in service at any given moment. More than 2 million died during the war. By contrast, American formations were fully motorized, relying on trucks and vehicles rather than animals for logistics. This difference produced advantages that German commanders recognized with envy. U.S. supply convoys could travel hundreds of kilometers in a day, while German columns, limited by the pace of horses, might manage only around 30 kilometers under favorable conditions. When German officers later analyzed their defeat, many pointed less to battlefield errors and more to shortages of material. Their troops fought effectively, and their tactical decisions were often sound, but their industrial output could not match that of opponents with far greater productive capacity. The Jeep became an emblem of this imbalance. German soldiers who encountered one saw a machine produced in such numbers that American units treated it almost as expendable, yet sturdy enough to require little upkeep. Its straightforward construction meant nearly any soldier could drive or repair it. Captured Jeeps were frequently preferred over German vehicles whenever they could be obtained. Decades later, in 1976, the U.S. Army began phasing out the Jeep in favor of the HMMWV after more than 3 decades of service. Even then, many examples remained in use among reserve forces and Allied armies for years afterward. That same year, Volkswagen marked the production of its 1 millionth Golf. Like the Beetle before it, the Golf reflected a combination of careful engineering and efficient mass production, an approach shaped in part by lessons learned from both German and American wartime experiences. By the 1982, West Germany had re-emerged as one of the world's major economies, exporting vehicles globally and pairing a reputation for quality with highly efficient manufacturing systems. The last reunion of the Africa Corps took place in 1998, attended by only a handful of aging veterans. During the gathering, someone mentioned that a nearby museum had acquired a restored Willys MB Jeep, and many of the former soldiers chose to see it. They gathered around the vehicle, studying it as mechanics and former fighters who had once faced it in the field. One elderly veteran reached out and ran his hand along the hood, recalling that he had captured a similar vehicle in 1942 and driven it for several months before being wounded at El Alamein. He described it as the finest machine he had ever handled, superior to anything available to his own unit. Another remembered examining one in Tunisia shortly before surrendering and being struck by how uncomplicated the design was. It convinced him that German vehicle development had often been overly intricate and difficult to manufacture or maintain. They reflected on the numbers, more than 60,000 American Jeeps produced versus about 50,000 Kübelwagens. That disparity, one of them said, explained much of the war's outcome. Standing quietly before the museum exhibit, they saw not merely a relic, but a reminder of the industrial strength that had overwhelmed them. It represented a philosophy of practical engineering, large-scale output, and reliability in quantity qualities that had reshaped warfare and, later, industry. German designers had once pursued technical perfection. Their adversaries had focused on building vast numbers of dependable machines. The lesson, learned by Wehrmacht mechanics who inspected captured vehicles across North Africa, Italy, and Western Europe, would influence post-war German manufacturing and contribute to its eventual economic recovery. The Jeep, in their eyes, had been more than transportation. It had been a teacher. After the war, German engineers and mechanics did more than learn how to repair American equipment. They analyzed why it had been built the way it was, uncovering the industrial principles that had helped the United States prevail. This hard-earned understanding became a cornerstone of Germany's post-war recovery and eventual economic revival. Defeat instilled a sense of humility, while American machinery demonstrated the value of practical engineering. Together, these lessons fostered a new German approach that proved far more effective than the overconfidence that had preceded the conflict. The experience of Wehrmacht mechanics with captured Jeeps illustrates learning through failure. Before encountering Allied vehicles, many believed German engineering's precision and complexity ensured victory. Reality, however, revealed that American vehicles, though not superior in technical specs, were better suited for the demands of modern warfare. They could be produced in huge numbers, maintained by minimally trained personnel, assembled from standardized parts, and remained dependable under harsh conditions. This combination of functional design and industrial scale created a material advantage Germany could not match, regardless of soldier skill or tactical prowess. Mechanics who worked on both German and Allied vehicles witnessed these differences firsthand. Their experiences shaped post-war reconstruction. Young mechanics were trained to prioritize simplicity and maintainability. Production processes emphasized standardization and new designs, focused on reliability and manufacturability. Engineers studying captured American equipment in prison camps combined German precision with American efficiency, creating a hybrid industrial model that underpinned West Germany's rise as a leading exporter by the 1972. The Jeep, seemingly modest, played a subtle but influential role in this transformation. Maintenance crews and officers alike recognized the vehicle's practical advantages, while the widespread presence of Allied equipment made clear the limits of German pre-war doctrines. Through these encounters, a broad understanding emerged that Germany's failure had been rooted more in production capacity than battlefield performance. Post-war planners drew heavily on these insights, embracing mass production over artisanal methods, standardization over over-engineered complexity, and functionality over perfection. The mechanics examining jeeps in North Africa in 1942 could not have foreseen the lasting impact of their observations. Their work offered a window into industrial strategies and production philosophies that would guide Germany's rebuilding. Though the last of these veterans has passed, the lessons remain influential. Contemporary design emphasizes manufacturability, reliability, and ease of maintenance principles the Jeep exemplified. The vehicle's legacy endures as a reminder that practical effectiveness often outweighs technical sophistication, and that humility, born of experience, can be a more valuable teacher than pride.